how to calculate the achieved power in a confirmatory factor analysis, CFA. In this tutorial, I'll show you how to perform a post-hoc power analysis for a CFA with the free software semPower. Let's say this is the CFA we have estimated, and maybe now we want to know how large was the power. At the end of this tutorial, you'll know how to do this. If instead of a post-hoc power you're interested in an a priori power analysis to plan your sample size, I've made another video about that. The link is in the video description. What I will be showing you is relevant for a CFA with most programs: lavaan, AMOS, Stata, Mplus, and so on. semPower is an R package, but the results are not limited to CFA with R. And you don't need to have prior knowledge of R. You just have to install R and run the code I'll be showing you. With a power analysis for a CFA, two very different questions can be answered. The first, you can perform a power analysis for the full model, because a CFA is a model testing approach, so you can test whether the model fits the data with the model chi-square test. And for that test, you can perform a power analysis. The second possible way to do a power analysis, you could run a power analysis for a specific effect. For instance, for a factor correlation, or for the difference between two factor correlations, or for an item loading. With semPower, you can do both types of power analyses. I will show you both. I will start with the easier case with the full model, and then based on that we will go on to the post-hoc power analysis for different specific effects in a CFA. As preparation, first you need to install R and RStudio. There are many tutorials on the internet how to do that. Then you have to install two R modules called packages, semPower and lavaan. With this code here, you have to do it just once. And each session you want to perform a power analysis, you have to load those packages with the library command, these two lines. With that out of the way, we are ready to start with our power analysis. To perform the post-hoc power analysis for the full model, we need a measure of the effect size. Here normally I would use the RMSEA. We need the sample size, and we need the degrees of freedom. You will get all three informations from the output of your SEM program. We are using the function semPower.posthoc, starting with the effect size. So let's say in the output we found an RMSEA of 0.055. We have to specify what kind of effect size measure that is, in this case RMSEA. Alpha error 0.05. This is the sample size and the degrees of freedom for our model. And with that information, we can calculate the power for the full model test. Here's the output. The power is down here. With a sample size of 200 and an RMSEA of 0.055, we have achieved a power of 0.546. In addition to this output, you will get a plot. For me, it's not that helpful, so I, in general, don't look at this plot. So that was the power analysis for the full model. Now we come to power analyses for specific effects. Let's start with a factor correlation. Let's say we want to calculate the ex post power for the correlation between factor 1 and factor 3. For that we actually need a lot of information, but all information you will get from the output of your CFA. First we need to specify a variance-covariance matrix for the factors. Here we have three factors, therefore we have three lines and three columns. On the diagonal the variances. In this example I had set the variances of the factors to 1, so therefore on the diagonal there are only ones. And then the covariances, or here in the standardized case, the correlations between the factors. Between first and second factor, first and third factor, second and third factor. With that we can go to the function semPower.powerCFA, type post-hoc, then V our covariance matrix, null effect. Here we specify what kind of power analysis we want to run. And here we want to get a power analysis for a specific factor correlation, so cor equals 0. With the parameter null which, we specify for which factor correlation we want to perform our power analysis. And in this case it's between factor 1 and factor 3. Then a list of the loadings. Normally I would use for all the input the standardized results. So here the standardized loadings, then the alpha error, and the sample size we've achieved. Here are our results. We've achieved a power of 0.724. The next possible post-hoc power analysis is about the comparison between two factor correlations. Let's say for our hypothesis we wanted to compare the correlations between factor 1 and factor 3 to the correlation between factor 2 and factor 3. For that again we use the function semPower.powerCFA, type post-hoc, Again, we need our V matrix. Here I used the same I specified earlier. What is new are the next two lines. Null effect now is core X equals core Z, to specify that we want to compare two correlations to each other. For null which, now we have to put in a list with, in this case, two correlations. Factor 1 to factor 3 and factor 2 to factor 3. With loadings, again, the list of the factor loadings, alpha, and the sample size. With our 200 observations, here we get an extremely small power with only 0.1568. So for a comparison of those two correlations, our sample was simply much too small. What's also possible is to calculate the post-hoc power for the test of a loading, if you want to test whether a specific loading is significantly different from 0. For that, I recommend specifying a lambda matrix, that's a matrix of the loadings. Earlier we used a loadings parameter with a list of loadings, but those loadings are all loadings on just one factor. So each item loads on just one factor. We could use this here as well. However, if you want to drill down deeper into loadings, maybe you have cross loadings. And with the lambda matrix, you can specify cross loadings. Each row in this matrix represents one item. We had 9 items, therefore we have 9 rows. And each column represents one factor. So this here is the loading of the first item on the first factor. In this example, we didn't have cross-loadings, but it would be easy to specify cross-loadings. If we had a cross-loading of the first item on the third factor, that would go here. Number of columns, of course, is 3 again, because we have 3 factors. And again, we use the function semPower.powerCFA, type post-hoc, V again the factor correlation matrix we specified earlier, and null effect now is loadings equal to 0. And null which denotes which loading we want to test. And in this case, it's row 4, column 2, that is this loading here, the loading of item 4 on the second factor. Lambda equals our lambda matrix we specified, and again alpha and the sample size. And here we get a very large power of 0.999. That's it for post-hoc power analysis for a CFA with semPower. Thanks for watching and see you in the next video.